There are a number of adapters, transformers, and other gadgets which are useful tools for solving an assortment of challenges that you may come across. Transformers are a type of inductor. Basically, in its simplest form, a transformer is a coil of wire wrapped around a metal core with another coil of wire interwoven around it in some fashion. Every electronic device, whether a simple calculator that plugs into the wall for power, to a microwave oven, to a TV set, will have a transformer, if not several, inside of it, or within its circuits. In most cases, these are step-down transformers inside the power supply of that device that convert 120 volt current down to something that the device uses, more likely a much lower voltage, like 10 or 20, 12, 5, 15 volts, depending on what the device is, within its power supply. This image is of the ubiquitous, hated, and typical Wall Wart power supply, which you will find with a large percentage of electronic devices. Most people curse these things because they're always getting lost, and you can only plug so many of them into the wall or so many into the plug strip before you run out of room. And because they're not exactly universal. In other words, you can't take this power supply from this piece of equipment and plug it into that piece of equipment. Most of them use some type of coaxial DC plug to connect to whatever device it belongs to. The problem is there are at least 4 common sizes of these plugs and perhaps 3 different styles for each size. This wouldn't be a problem if they were made so that X style is for 5 volts and Y style is for 12 volts and so on. So there's a common theme behind the things. There is not, which is dangerous in a way because you could accidentally plug a 12 volt wall wart into a device that only wants to see 5 volts, and mechanically the plug might fit. Having these things universal or having some logical system to them or a standardization would make way too much sense now, wouldn't it?
Most of this stuff is certainly ahead of my taste. I don't like it. And if I'm wrong, I'm sure you'll correct me.
The reason we have to contend with these things is that in many devices, 90% of the power supply for that device is in the wall wart. Now, for some devices that are also capable of running on battery power, having an internal supply doesn't make a whole lot of sense if you can swap it out with a battery pack. It depends on what the device is intended for. In some cases, having an internal supply in something that is designed to run on batteries may double and triple the size of the device and make it heavier. So if you want to run it on batteries, it means you're going to carry it around. You don't want something heavy. Something like a GoPro camera, its power supply is nearly as big as the camera itself, as seen in this picture. The other reason has to do with lawyers. Yes, you know, the same guys that are giving you high insurance rates, huge medical bills, you know, these guys.
Were you killed in a car crash? Did you get run over by a bus? Did you OD on drugs? One call does it all. Dewey, Cheatham, and Howe, Esquire. We'll throw the book at them. We got lunch.
Basically, to put an AC or main supply inside of a given device requires a UL rating, or in Europe, their equivalent. This rating ensures that the device and its power supply represent a safe, fireproof environment, or an environment that's not likely to catch on fire from overheating or other problems, or that there's no danger of electrical shock if the device is not properly designed. This keeps the product liability insurance rates, you know, those guys, down for the manufacturer. But it also costs a lot of money to get the UL rating, which makes it simpler just to put an external DC power supply on it that you can buy in bulk from another manufacturer. So if something goes wrong with that little DC wall wart, the manufacturer of the device it plugs into can point his finger at them. So enough talk about the accursed wall wart. In the world of audios, transformers designed for audio signals are present in a lot of gear. Most serious analog audio consoles, particularly vintage units, are filled with them. Every input will have them, every output will have them. This is also part of what makes a lot of them very heavy, because some of those transformers were quite big back in the day. In some cases, the transformer is an impedance matching device or is part of the microphone preamp gain stage. The ones on the output side of that console are either impedance matching devices or strictly an isolation transformer, depending on the design of the audio console. Transformers used for audio signals fall into 3 basic types: matching, bridging, and isolation. A matching transformer is something that takes an item like a 200 ohm microphone and matches it to the 15K ohm input circuit on a piece of equipment or an old audio console. This type of matching can be done without an input transformer, but it creates a different sonic texture. People have written books, a lot of books, about the merits of transformers versus transformerless circuits in audio console designs. I won't go into that here. Bridging transformers can either be used to connect 2 devices of differing impedances or 2 different impedances to create an impedance loading within the devices that's constant between the devices, if that makes any sense. Isolation transformers, if made correctly, are designed to electrically isolate 2 different devices or 2 different systems. Isolation transformers are also available for AC power, but that's an entirely different subject I'm not going to get into here. Of all the things to have in your toolkit, a couple of small isolation transformers are a must-have. There are several different companies that make these in several different configurations. By far the most common ones are made by a company called Sescom, and the model of that transformer is an IL-19. So if anybody says, get me an IL-19, you'll know what they're talking about. The IL-19 itself is a 600 ohm to 600 ohm isolation transformer. Sescom and other companies also make a 10K ohm to 10K ohm version and other variations on that scheme. The units in these pictures are not seen very much these days, as they are kind of a low-budget version of a direct box, basically intended to connect a guitar or other unbalanced source to a balanced input. It is not unheard of, however, to find 1 or 2 of these things kicking around in the adapter kits that some production companies send out to show site. But they are typically cheaply made things, made in China, made in Taiwan, Radio Shack was famous for carrying a wide assortment of these things in different configurations. They might get you through something in a pinch, but I wouldn't want to stake a show on one of these things because they typically are not made to be very durable or robust or made with very good quality components or very good quality transformers inside of them. If you really wanted to connect a guitar or something like that to a PA system or to a mixing console, you're better off using a direct box or something actually designed to do that. Well, that's all for this episode of Mr. Warren's Audio Hood. Please join us again soon for the next exciting episode of Mr. Warren's Audio Hood, audio and AV training for the real world.